Welcome to Study Loop.
This is the answer to Chapter 13, problem number 15 from the Smith Organic Chemistry textbook. And in this problem, we are asked, how do the IR spectra of the isomers cyclopentane and 1-pentene differ? And so I need to apologize and correct this. I drew cyclohexane for some reason. So let me redraw this quickly, and then we can talk about the answer to the problem. At least I caught it now rather than answering the entire problem and then realizing that it was wrong. So cyclopentane, of course, is going to be a 5-membered ring. Okay, so there we go. There's cyclopentane, and I do apologize. And so basically, in order to solve this problem, we're going to need to go up a couple pages in the textbook and look at table 13.2. And so table 13.2 lists important IR absorptions. And so basically, we need to look at these two molecules and determine what types of bonds we have in these molecules. So we have carbon-carbon single bonds. They don't really show anywhere on this table, so that's fine. So we have carbon-hydrogen bonds. So in cyclopentane, we have all C-sp3 H bonds. And C-sp3H bonds, we're told from this table, 13.2, are going to show between 3,000 and 2850 wave number. So 3,000 to 2850 wave number, which again is centimeters to the -1. And so we have some C-sp3 H bonds in our 1-pentene also. So they're also going to show at 3,000 to 2850 wave number. Okay. And so really in cyclopentane, that's all we have, right? We have carbon-carbon bonds and carbon-hydrogen bonds. And so we're not going to really expect to see any other absorptions from cyclopentane. However, 1-pentene also has a carbon-carbon double bond. So a carbon-carbon double bond, according to this table, is going to show at 1650 wave number. So the carbon-carbon double bond is going to show at 1650 centimeters to the -1. So there's our first difference, right? We're not going to see that particular peak in the IR spectrum of cyclopentane. And so also here we have some, oops, and I forgot the 3. So, okay, there we go. And so also here we have some C-sp2 hybridized carbons with hydrogens on them. And so those are actually going to show at 3150 to 3000. So we expect to see the C-sp3H bonds, but we also should expect to see these C-sp2H bonds. And so again, they show at 3150 to 3000. Okay, and so that's really when the problem asks what is going to be the difference between these two spectra, well, the difference is going to be that the 1-pentene is going to show these two peaks, whereas the cyclopentane is not. Yeah, and so that's the way to approach this problem. We just need to look at table 13.2 and then determine what kinds of peaks each of these molecules is going to have. And then once we do that, it's pretty apparent the two extra types of peaks that 1-pentene will have that cyclopentane will not.